Okay, okay. All right, here's, I think we need to just kind of, this probably is valuable. Even if you did well on this, you didn't get, depending on what questions you got, there may be something here that you didn't get. Two things I want to do with this. And this is a really hard test. I mean, a really hard test, and I acknowledge that. But I don't want to give up on this. I know I could just rewrite the test and make it a little easier and we could move on, but that's not what we want to do. You guys are going to be research scientists and engineers, and you can't give up in the face of problems. You just gotta push on and get through this. All right, so there's two things you want to look at. Let's look at problems we're having with the calculus, and there are some, guaranteed. But then let's also bear in mind that this is a graphing calculator test, and I sincerely want you to know how to use that thing. You can legally cheat on graphing calculator tests by just knowing how to use it really well. You can sidestep a lot of math. We're gonna cycle through this stuff again and again, and you're gonna have to do a lot of this stuff without a graphing calculator. And so you need to know how to do it, and we'll continue to work on that stuff throughout the year. But as we, in parallel, I mean, if you have some hints or some suggestions, throw them out there. Let's see if we can find some ways to do this stuff graphically also, because it's a great tool, and you got to know how to use it. Okay, so find an equation for the line tangent to the curve at the given point. They just give us an x value, all right? So don't jump into it. You got to think big picture here for a second. What's our strategy? What are we going to do? How can we do this without, there probably are some graphing calculator tricks, but just for a second, let's talk about how we would use analysis and calculus to do this. What's our mathematical approach if we want to find the equation of a tangent line? And it helps to work backwards. What are the ingredients of a line, tangent line, any line? Slope and a point. Yeah, we need a point and a slope, right? How are we going to find the point? Plug in x. Absolutely. That's how we always do it, right? We're given a function. We're given a value of x. Evaluate the function at 1 and find the y value. There's my point. Easy. Non-calculus stuff. How do we find the slope? Take the derivative and evaluate it at 1. Sure. And that tells us the slope of the curve, meaning the same thing as the slope of the tangent to the curve at x equals 1. So there's our strategy. None of that stuff is that hard. Now we can kind of focus on the nitty-gritty here. The non-calculus stuff is easy. Let's get that out of the way. Let's find the point, I guess. So you said plug x in, and so at x equals 1, y would equal what? 1. Yeah. Everybody agree? Yeah. Maybe 4 over 4. So that gives me the point 1, 1. Okay, now let's move on and do the calculus. So we need the derivative. Now, talk to me about the calculus here. Well, how are we going to approach this derivative? What does it look like right there? Quotient. Can we avoid the quotient rule? Because that one's messy. Yes, we can. How can we do that? Okay, good. Pull the 4 out front, divide the x through into both terms, right? And we can make both of them powers of x. So we rewrite this as 4 times the quantity, and then what's x cubed over, 1/4, not 4, right? What's x cubed over x? X squared plus 3 over x is x to the minus 1. Good. Okay, so that makes the calculus pretty simple then. So y prime equals 1/4 times, what's the derivative of x squared? 2x. Derivative of 3x to the minus 1. Okay, minus 3x to the minus 2, and I'm just going to jump right to that, writing it like that. Okay, no need to simplify, not that there's really any simplifying to do, but there's no need to simplify because we want a number anyway. We just want a value of the derivative. So don't waste time doing unnecessary algebra. Just plug in the 1. So at x equals 1, y prime equals what? What's that going to give us? Yeah, negative 1/4, right? I'm gonna get 2 minus 3 is negative 1 times 1/4, so there's M. Got a point, got a slope, is K, right? So then how do we find the equation of a line? There's a bunch of ways we could, but take your pick. What do we do? Y equals mx plus b. I know M, just gotta find b, right? So I'll plug in negative 1/4 for M. What about x? 1. Y is 1. So what's b then? I'm going to get 1 equals negative 1/4 plus b, 5/4. Yeah. Okay, good. And we get the equation y equals negative 1/4 x plus 5/4. And let's just check ourselves. Just make sure. There we go. How about that? Okay. That was the most commonly missed problem on the graphing calculator test, believe it or not. I would not have anticipated that. I don't know. People must have just breezed through that one. Okay, here's next one. Find the derivative of this trig function. Now this one, it looks a little harder because it's, we got cotangents and cosecants and all that good stuff. So how are we going to differentiate this? This is just a straight derivative, just calculus here. What's our... okay, so you mean we're going to use the power rule? Yeah, good. So it's going to be a chain rule problem where I've got some layers here. I've got a bunch of stuff to the negative 1. So the first layer is I've got negative 1 times a bunch of stuff to the negative 2. Good. Okay, so y prime equals negative the quantity cotangent x minus cosecant x to the negative 2 times, let me move that down a little bit, that's going to be, okay, times
Cheyenne Carey to the front office, please. Cheyenne Carey to the front
an
office.
ugly derivative. Now I've got to take the derivative of all the stuff, right? So I'm gonna open up a big set of brackets for that derivative. Okay, so what's that gonna look like? I've got to take the derivative of cotangent x minus cosecant x. So what's the derivative of cotangent x? Negative? Okay, remember our rule. It's easy to remember. If you're differentiating any of the co-trig functions, you always get that negative sign in there, right? It's always a coefficient of negative 1. Okay, minus the derivative of cosecant. Good, it's going to be minus a negative, isn't it? So plus, derivative of cosecant is negative cosecant x, cotangent x. Okay, so there's our answer, right? Okay, so then we're going to have to write this on the bottom, right? So we get equals negative. Well, we can distribute that through too if we want. So yeah, let's do that. So if I distribute the negative through the top, it's going to make that first term positive and the second term negative. Everybody see that? Okay. So cosecant squared x minus cosecant x cotangent x. Okay. And then on the bottom, I've got the quantity cosecant, whoops, cotangent x. Well, I distributed this negative.
Oh.
I already did that, right?
Oh.
Okay. So then I've just got a cotangent x minus cosecant x quantity squared. Okay, now that's pretty good, but there is something we could do here. And I want you to see this. This algebra is important. I think you have to do this probably to get full credit. What can we do? Is there any way we could cancel a factor top and bottom? Can I factor something out at the top? It's hard to factor out. Now, it's a good idea, but I'm going to caution you here. It's hard to factor something out of the bottom because we've got an exponent there, right? It's much easier to factor something out of the top. So, is there a common factor on the top? Cosecant. Good. Now, we'll look and kind of look ahead here, and this is part of this developing skill set you got for calculus is, can you see what you're going to get when I pull that cosecant out? You're going to get cosecant minus cotangent, right? Now look, that's almost what we need, isn't it? We need to have the opposite. There you go. Bingo. Factor out a negative cosecant. There it is. There it is. So if we factor out a negative cosecant x, look what we're left with. Then we're going to be left with a negative cosecant x plus cotangent x. Well, why not flip those around, right? So we'll get cotangent x minus cosecant x. Now that's a lot of, I skipped some steps there. Everybody, I want to make sure everybody sees what we did. That's the numerator there is all we're working with. Okay, give me a 1 to 5 on that. I want to make sure, how 5 meaning I got it completely, 1 meaning I don't get it at all. Okay.
Wait, what?
Okay. All right. Well, okay, maybe not the first time. Maybe not the first time, but here's the key. What you're looking to do, when I've got a bunch of trig stuff here, right? Why might this be triggered in your brain in the future? Because I've got a difference on the top and I've got a difference being squared on the bottom of factors, right? And so when you see that setup, you got to always be automatically thinking, okay, now is there a way? Could I pull something out of both terms on the top and get some cancellation? Could I pare down each of these by factoring something out so that they would match up with that factor on the bottom? You always want to check. It's not always going to work, but you always want to check and see if you can. Okay. So on the bottom, then I've got my cotangent minus cosecant x squared, and those are like bases, right? Okay. And so what I can do then, everybody sees now I can cancel that with one of those, and that's my answer. Okay, so we get minus cosecant x over cotangent x minus cosecant x. And there's lots of room for error there, but we got it. There's our minus sign up front. Okay.
So like, why can't you cancel out like the minus cosecant x this, like in your final?
Okay, because you can't, good. Now, because you can't do that. Can't do that in algebra. In algebra, the question is, why couldn't we do this? Why couldn't we cancel those? Because it's a difference. You can't do that because that would be like saying this. That would be like saying A over A plus B equals 1 over B. Try it with numbers. If I have 2 over 2 plus 3, or 2 minus 3, that's 2/5, right?
Yeah.
If I cancel those, it would look like 1/3.
Yeah.
They're different. You can only, and the rule is, you can only cancel common factors, things that are being multiplied, right? And because this cosecant on the bottom is being subtracted and not multiplied, can't do it. Okay? So let me undo that so it doesn't look like we actually did that step. There we go. Okay, now we're set. All right, that was a good one. That was a good problem to go through. Okay, find the points on the curve. We're obviously not going to get through nearly all of this, but we'll get through this one, I think. Find the points on the curve y equals some polynomial where the tangent is parallel to the x-axis. Okay. Okay. Say it again. You really could. I mean, this is one. So on your calculator, here's one where you could just find all the places where the slope. So you have to differentiate first, though, right? Yeah. Take the derivative and then just find all the zeros of the derivative. Okay. So that's pretty easy to do.
Mori Yoshioka, come to the office, please. Mori Yoshioka, come to the office.
So we get y prime equals what? 6x squared minus 6x minus 12. And then all we're going to do is set that derivative equal to 0 and solve. And we could do this one. We could throw this in the calculator, but let me just show you real quick here. is there something I could divide away from both sides? 6. So this is gonna get real easy. X squared minus x minus 2 equals 0. Yeah, are there two magic numbers that multiply to -2 and add to -1? Yeah, -2, +1. So x equals 2 or x equals -1, right? And then it wants the points, so I just got to feed those values back into my original polynomial to get the y values then, right? Okay. Piece cake, piece cake. You know, while we're at it, I kind of forgot to bring this up, but could you have, well, that one you couldn't do on your calculator at all, could you? Nothing, couldn't help you on that one. You're stuck just doing some calculus there. This first one, we got a way you could use your calculator on that one? There's a tricky way you could do it.
You could put it all in, you could do y equals and then do the dy over dx, or calculate and then do the derivative, and that gives you the slope, and then do that x equals 1.
Bingo. Let me just show people that. And I hate to, you know, I mean, but this is, you can do this. I mean, it's. It's legal cheating. How often do you get to legally cheat? That's pretty good. Maybe. Okay, so we could actually do this, couldn't we? We could find an equation for the tangent to the curve at the given point. So if at x equals 1, we could graph, we could go into y equals, where, we could graph the function, so the quantity x cubed, this is pretty slick, x cubed plus 3 divided by quantity 4x. Okay, and let's just try going zoom fit, just see if that works. If we can see anything. Looks like we can see stuff pretty well. So if I put in x equals 1, now watch this, I can go second calc, dy dx, derivative, plug in x equals 1, hit enter, and it tells me that the slope is -0.25000. What's it trying to say? 1/4. Good. It's trying to say -1/4. And so if I know, look what that did. That got me clear down to there. And from there it was really easy, right? Make sense? Okay. How about that? I don't know what happened to it. Legally cheating, that's right. Well, we're back. So I don't know if you can get away with it out with. Oh, you know what you might get away with? You might get away with saying that the 55 sign wasn't very specific. You know, velocity is relative. You don't know what, maybe you thought it was 55 relative to the car in front of you. I don't know. It wasn't specific. It didn't state the reference frame. Try that one. There you go. I hold myself blameless if you get excited for harassing officers. This one. Okay, I don't think we're going to have time. We got 2 minutes. Let's start it, okay. Well, let's talk about it. So find dy dt here. So we got now first thing we want to do, we'll at least get this far, is we got to rewrite this thing so we can see, at least for now, so we can see all the layers. It's confusing when you got this 2 here. What is the outside layer of this function actually? Cosine. Well, which one is it? Cosine or squared? Squared. It's a power function, and it's hard. Sometimes you want to, you might see it as cosine. So let's rewrite this as y equals the quantity cosine of 7 pi t minus 2 squared. So you can see that there are 3 layers, and the outside layer is a power, right? And so then we just got to go through 3 links of the chain rule, right? And that's where it gets a little tricky. But we're out of time. Yes, we will. I think we'll. Honestly, honestly, I think we'll carry on tomorrow in class. I hate to, I mean, I'm anxious to have you try this stuff, but I wanna, your test scores were really low, and I wanna make sure that before we go back in there, we've seen it thoroughly. Oh,
Well, you get 2 cosine quantity times negative sine
right,
quantity
good. Times
7 pi.
times negative sine,
Yeah,
right,
yeah.
of that.
Negative sine quantity.
Okay, times 7 pi, right?
And then you just have to simplify that?
Yeah, that's it.
7 pi.
It sounds so simple.
Yeah.
Well, it's so
That's it?
Okay, so you might have been a negative sign on the derivatives. You gotta know the derivatives. Go learn those. There's no, I mean, my goodness. Here we're talking about all this sophisticated calculus, and this is just memorizing a couple flashcards. Go memorize the flashcards.
Yeah, Jacob, you make it sound so simple.